Hi, we're going to be solving trig equations today. We really need to know our unit circle values, and sometimes thinking about the graphs can help us as well. I think you should be pretty comfortable with these, but if not, we can certainly talk about them. So remember, there's a distinction between solving on 0 to 2 pi and finding all solutions. So if I have sine theta equals 1/2 on 0 to 2 pi, when is the y value equal to 1/2? Oops, on this interval, and I get pi over 6 and 5 pi over 6 as my answers. But if I were doing all solutions, then I would have pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Okay? Remember, there's a distinction, so pay attention in the question as to whether we're 0 to 2 pi or all solutions. Okay? All right, so pull out those whiteboards, even if they're just figurative. Get your notes ready, and let's start solving. Secant squared theta minus 4 equals 0 on 0 to 2 pi. Oh yeah, I'm waiting for you to solve this. Okay, so I know secant squared theta equals 4, and when I take the square root of both sides, what is it that I'm supposed to remember? That's right, don't forget that plus or minus. So secant theta equals plus and minus 2, and that means that the cosine of theta, the reciprocal of secant, would be the reciprocal of this, plus and minus 1/2. When is cosine plus and minus 1/2? Well, theta would be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Those are my 4 solutions. Okay. How about this one? Root 3 plus 2 sine theta equals 0, and I want all solutions. Okay. 5, 4, 3, 2, 1. So I know that sine theta should equal negative root 3 over 2, and that happens twice. Once at 4 pi over 3, and the other time at 5 pi over 3. Okay, don't forget the plus 2 pi n's. All right, how does this change if we do this? Root 3 plus 2 sine 3 theta equals 0. And again, I want all solutions. Well, when I do all solutions, I'm still getting sine 3 theta equals negative root 3 over 2. And I'm saying to myself, what angle has this? So 3 theta would be 4 pi over 3 plus 2 pi m, and 5 pi over 3 plus 2 pi m. But that's what 3 theta is. I need to know what theta is. So I have to divide everywhere, not just here, but here and here as well. So 4 pi over 9 plus 2 pi over 3, and 5 pi over 9 plus 2 pi over 3. Don't forget the n's. Okay, so I don't go around 3 times picking up solutions. I only go around once, and then I divide everything, including the 2 pi n's, by that 3. I only go around 3 times if it's on 0 to 2 pi. Oops. On 0 to 2 pi, I'm going to say, okay, when are we this? We're at 4 pi over 3, 5 pi over 3, and then I have to add 2 pi to go around another time, 10 pi over 3, 11 pi over 3, and then I've got to add 2 pi to go around another time. And so now I've gone around 3 times picking up solutions, but that's what 3 theta is equal to. I need to know theta, so I need to divide everywhere by 3. 4 pi over 9, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, 17 pi over 9. So let's summarize that. When I have a multiple angle in here, all solutions, I go around once, I slap on the plus 2 pi n's, unless I'm doing tangent or cotangent, and then I'm slapping on a pi n, and then I'm dividing by b everywhere. This is different than 0 to 2 pi, where I'll go around b times picking up solutions, and then divide all solutions by b. Okay? All right, so see what you can do with this one. 2 cosine 2 theta minus root 3 equals 0, and let's do 0 to 2 pi. Okay, so we know that cosine 2 theta equals root 3 over 2. And I'm on 0 to 2 pi, so I have to go around the unit circle twice picking up solutions. Because I know my unit circle values, I'm able to say when the x value is root 3 over 2, and that happens at pi over 6 and 11 pi over 6 the first time around. I've got to go around again, so I have to add 2 pi to each of these, 13 pi over 6 and 23 pi over 6. But that's what 2 theta equals, and I want to know what theta is. So pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi over 12. Okay? How would this be different if I had said over here, all solutions? Why don't you do that one now? Show me what you get for that. Okay, so with all solutions, remember, I only go around once, and I get pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. I only go around once, I slap on the plus 2 pi n's, and then I divide everywhere by 2. So theta equals pi over 12 plus pi n, and 11 pi over 12 plus pi n. These are our solutions. Okay? All right. Let's move on. How about something like this? Root 3 tangent x over 2 equals 1. And I'm looking on 0 to 2 pi. Some people get this far and get stuck. And so I want to remind you that while I may not know 1 over root 3 on the unit circle, root 3 is familiar if I divide it by 2. And so if I divide the bottom by 2, I have to divide the top by 2. So when is sine equal to 1/2? When is cosine equal to root 3 over 2? That's going to happen at pi over 6. Does it happen any other times? Well, what if both of these were negative? So when would that happen? Well, that would be 7 pi over 6. Now, this is a 1/2. So how do I go around? I'm not sure. Well, let's just try something out, okay? And we're doing 0 to 2 pi. So I know that this is a number less than 1, so I don't have to go around more times. But now that's what x over 2 equals. Let's multiply by 2 everywhere. And so what do we get? We get x equals 2 pi over 6, which is pi over 3, and x equals 14 pi over 6. Or that's the same as 7 pi over 3. Now, here's the thing. Our solutions have to be on 0 to 2 pi. 2 pi is 6 pi over 3. This, too big. What am I supposed to do with this? I'm only supposed to take solutions from halfway around the unit circle. Only solutions from 0 to pi. Only halfway around. I don't go around twice. I don't go around once. I only go around halfway. This other solution, this 7 pi over 6, this is over here. It's more than halfway around, and therefore when I multiply both sides by 2, I get an answer that's outside of my domain. So either I catch it on the front end where I say I'm only going to go picking up solutions halfway around, or I find the two solutions from going once around and have to discard one of them. Whichever works easier for you is what I recommend you stick to. Okay, speaking of tangent, tangent squared x sine x equals sine x, and I'd like to solve this on 0 to 2 pi. I'd also like to chase any of you with a stick or a switch if you do this. If you do this, you're throwing solutions away. Don't do that. Don't divide by a trig function, unless you absolutely have to. Instead, in this problem, we want to subtract sine x from both sides. So that's going to give me tangent squared x sine x minus sine x equals 0. I see two terms on the left side of the equal sign, and I notice that they both have a sign in common. So let's factor out a sine x. Tangent squared x minus 1 equals 0. And now I can set sine equal to 0 and tangent squared x minus 1 equal to 0, which gives me tangent x equals plus or minus 1. Right? I'm going to add 1, I'm going to take the square root, and when I take the square root of both sides, I have to remember the plus and minus 1. So, what are my solutions? Well, I know that sine is equal to 0 for 0 and pi. I know that tangent is equal to 1 at pi over 4 and 5 pi over 4, and tangent is equal to negative 1 at 3 pi over 4 and 7 pi over 4. If I had done this problem by originally dividing both sides by sine, I would have been throwing those solutions away. So please don't divide by a trig function if you can help it. All right, what's next? How about 2 cosine squared theta plus cosine theta equals 0? And let's do all solutions here, okay? I think you can do this one. That's right. I need to not subtract cosine from both sides, but instead I need to factor a cosine out. 2 cosine theta plus 1. And so now I've got cosine theta equals 0, 2 cosine theta plus 1 equals 0, or cosine theta equals negative 1/2. So when does cosine equal 0? Cosine equals 0 at pi over 2 and 3 pi over 2. But we're doing all solutions. When does cosine equal negative 1/2? When theta equals 2 pi over 3 and 4 pi over 3. So these are the 4 solutions that I might write. Now, I hear some of you saying, but Mr. Kukla, couldn't you condense these? Yes, of course you can. Good observation. So this is pi over 2, and this is 3 pi over 2. But let's think about it this way. How far is it from here to here? From pi over 2 to 3 pi over 2. Well, if I do 3 pi over 2 minus pi over 2, I'm going to get 2 pi over 2 for pi. What about going this direction? Well, that's the same distance. It's also pi. So the distance between my answers is always pi. So I could actually do this. Instead of both of these, I could do pi over 2 plus pi n. Because pi n will pick up these and these. And so either I write all 4 of these, or I write these 3, because this takes care of those 2. Okay, next. What if I change that problem slightly and do 2 cosine squared 3 theta plus cosine 3 theta equals 0? And let's do both here. Let's do first 0 to 2 pi, and then do all solutions. Why don't you first try 0 to 2 pi, and then we'll compare answers in a minute. Why don't you pause the video, solve that equation for 0 to 2 pi, and then come back when you're ready to check your answer, or if you get stuck. Okay, so on 0 to 2 pi, I'm going to factor out that GCF and be left with 2 cosine 3 theta plus 1. Now I have to set each factor equal to 0. And now I have to find the solutions on 0 to 2 pi. Well, because I'm on 0 to 2 pi, I have to go around 3 times picking up when cosine, or the x value, is 0. So 3 theta will be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and 11 pi over 2. But that's what 3 theta equals. I want to know what theta is, so I have to divide everywhere by 3. You're welcome to simplify those fractions. I'm not going to bother. How capricious of me. Oops, that's a 6. 11 pi over 6. And 11 pi over 6 is just under 12 pi over 6, or 2 pi. So these are my answers between 0 and 2 pi. All right, so that was doing the problem on 0 to 2 pi. Why don't you pause the video now and try doing the problem? Oh wait, that was only this part. I still need to do this. Silly me. When is cosine equal to negative 1/2? At 2 pi over 3, at 4 pi over 3, at 8 pi over 3, at 10 pi over 3, at 14 pi over 3, and 16 pi over 3. But that's what 3 theta is. So my answers for this part will be 2 pi over 9, 4 pi over 9, 8 pi over 9, 10 pi over 9, 14 pi over 9, and 16 pi over 9. Oh, so many answers. Wow, that was a lot of answers. Is that 12 answers? Okay. Now what about the all solutions case? Take a minute to find the all solutions. Come back when you're stuck, or if you have a question, and we'll take a look at it together. Okay, welcome back. We're looking for all solutions. And so with all solutions, I only go around once picking up solutions. 3 theta equals pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, and over here, 3 theta equals 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n. Good. I only go around once picking up solutions. I slap the plus 2 pi n onto each of these, and then I divide everywhere by 3. And so my answers then are going to be theta equals pi over 6 plus 2 pi n over 3 pi over 6 plus 2 pi n over 3, 2 pi over 9 plus 2 pi n over 3, and finally 4 pi over 9 plus 2 pi n over 3. Yes, you could condense these, so if back here you had written pi over 2 plus pi n, and then divided everywhere by 3, you'd end up with this. That's also a condensed form of these two. You'd still need these two, okay? All right, a couple more solving problems. How about this one? How about sine squared x plus sine x minus 6 equals 0? Okay, so what's that going to get me? Well, that's sine x plus 3 and sine x minus 2 when I factor. And if I set each of those factors equal to 0, I get sine equals negative 3 and sine equals positive 2. Now, think about this for a minute. Think about your sine graph. Okay, here's my sine graph. It's only part of the sine graph, of course. On the midline, up to the high point, back down. Here's my sine graph. This point here is pi over 2, 1. This point here is 3 pi over 2, negative 1. We're asking the question, when does the sine graph intersect the line y equals negative 3? The black line doesn't intersect the red line, Mr. Kukla. That's right. That doesn't give me any solutions. And then we're asking the question over here, when does the sine graph intersect y equals 2? Here's y equals 2. When does this black sine graph intersect this blue y equals 2? Well, Mr. Kukla, it doesn't. That's right, it doesn't. So there are no solutions here. Okay? When I say we need to learn to think graphically, this is another example of thinking graphically, right? I need to think about my sine graph, its high points, its low points, and when it could intersect these horizontal lines. Okay, what about this? What am I going to do in this situation? Sine x equals negative 0.4. Now, this is a little troubling because I know this is between negative 1 and 1, so I know that the sine graph does intersect that number at some point, but I don't recognize this as a y value from the unit circle. And if I'm on 0 to 2 pi, I expect sine to be negative twice. Once over here in third quadrant, once over here in fourth quadrant. So I need to find two solutions. Well, you know, one thing we saw in the last video was that an inverse trig function can cancel out a trig function. So I can get x equals sine inverse negative 0.4. Okay, but I remember from doing the sine inverse stuff that I only get one solution, and I know by looking at my graph, there should be two solutions. So you could do this, or even do this on your calculator to get a value. Mode, radians, inverse sine, negative 0.4. And I get negative 0.4115. Well, wait a second. If this was on 0 to 2 pi, I'm really screwed because that's not on 0 to 2 pi. What am I supposed to do here? Well, look, you picked up the calculator anyway, right? Don't we live in the century where we can use that graphing calculator to graph things? So let's go graph. Let's put in y1, no, too dark. Let's put in y1 sine x, And let's put negative 0.4 in y2. And let's set up our standard viewing window going from we want to go from 0 to 2 pi, because we're doing x min and x max in steps of pi over 2. And then y values, my minimum y value should be -1, my maximum should be +1. I made sure to check that I was in radians, and I hit graph. So there's my sine graph. Ooh, and there's -0.4 graphing. And then I just do second, calculate, intersect. And I bring my cursor close to the point of intersection, hit enter 3 times, and I get the first point of intersection is 3.553195. Okay, and then the second point of intersection, second, calculate, intersect. I'm going to come over to this point of intersection now and find it. I don't have to actually get there, I just have to get kind of close to there. 1, 2, 3. And I get x equals 5.871668. So remember, we're writing sentences. Sine x equals -0.4 for x equals this and x equals that, period. Sine x equals -0.4 for x equals this and x equals that, period. Okay, it's not hard to write sentences, but you do need to be in the habit. Okay, so then, what can we do with this one? 6 sine squared x minus sine x minus 1 equals 0. Okay, so does it factor? 2 sine x, 3 sine x, 1, 1, minus plus equals 0. So I get sine x equals 1/2 and sine x equals -1/3. Now, if we're on 0 to 2 pi, I know that sine is equal to 1/2 when x equals pi over 6 and 5 pi over 6. But I don't recognize this from the unit circle. It's between -1 and 1, so I know that upness exists, but this isn't a place where I'm going to have to pull out my calculator and graph -1 divided by 3. And I see 1, 2 points of intersection. I can use my calculator to find those 2 points of intersection. I get 3.481, and second, calculate, intersect. Bring my cursor close to the other point of intersection and hit enter, 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 and I get, what? It found the same point again. Second, calculate, intersect. I guess I didn't get close enough to this other point of the intersection. And so it found the same one again. Okay, I'm definitely close to that point of intersection. 1, 2, 3. And so I've got 5.943. Okay, so x is. There's my sentence. All right. Okay, so what are you going to do in this situation? Tangent x plus secant x equals 1. Well, in this situation, I could try and rewrite things in terms of sines and cosines, but that's not going to help as much as you think it will. Instead, I'm going to square both sides of the equation. So I'm going to have tangent squared x plus 2 tangent x secant x plus secant squared x equals 1. Okay, and we'll be on 0 to 2 pi for this one. So what can we say? Well, you know, tangent squared x plus 2 tangent x secant x plus secant squared x minus 1 could equal 0. And then don't we know what secant squared minus 1 is? That was one of our rewritten identities. That's tangent squared. So tangent squared plus tangent squared is 2 tangent squared plus 2 tangent x secant x equals 0. Now what? Is there any GCF we could factor? Take out a 2 tangent x. Tangent x plus secant x. I'm sad. I'm sad because that's what I started with. Except now, it's equal to 0 and not 1. All right, well, let's see if I can take this further. So over here, we know 2 tangent x equals 0, or tangent x equals 0, and that happens when x equals 0 or pi. But what about this other one? Tangent plus secant equals 0. Tangent x plus secant x equals 0. Well, that's sine x over cosine x plus 1 over cosine x. And that's 1 plus sine x over cosine x equals 0. So if I multiply both sides by cosine x, something I really don't want you to do, but which I said if you do it if you have to, I get 1 plus sine x equals 0, or sine x equals negative 1. When does sine equal negative 1? When x equals 3 pi over 2. So it looks like I have 3 answers here. But you know, this was a really scary problem. So let's try it graphically. Let's type in y1 tangent x plus, how do I do secant? 1 divided by cosine x. And then in y2, I'm going to type in 1. Okay, I'm still on 0 to 2 pi. So let's graph. Oh, wait a second. My y max is 1, but I need this to intersect the line at 1. So I want to go a little higher than 1. I'm going to go for a y max of 2. So I have a little breathing space. Graph. So what do we see? And how many solutions do we see? Well, I see 0, and I see pi over 2, and I see 2 pi. Did I type that in right? Tangent x plus 1 over cosine x equals 1. It sure does. Well, but wait a second. This one wasn't right. And that one didn't exist. So let's go back and check our work. Okay? What had I said to do? I had said that I was going to square both sides. So I got tangent squared plus 2 tangent x secant x plus secant squared. And then I subtracted 1 from both sides. Secant squared minus 1 is tangent squared. Tangent squared plus tangent squared is 2 tangent squared x plus 2 tan x secant x. We then factored out a 2 tan x. We were left with tan x plus secant x equals 0. When does tangent equal 0? Tangent equals 0 at x equals 0 or pi. And what about this? Well, you know, I could do when does tangent x equal negative secant x, but I don't know that. So I rewrote this in terms of sines and cosines and had sine x plus 1 over cosine x. And so I multiplied both sides by cosine to get rid of the denominator, and I had sine x equals negative 1, and that gave me 3 pi over 2. So I'm expecting 0 pi and 3 pi over 2. Well, let's check our viewing window again. Our viewing window goes from 0 to 2 pi in steps of pi over 2. And my y values go from -1 to 2. I did type in tangent plus secant and 1. Okay. And I see 1 point of intersection, 2 point of intersection, 3 points of intersection, but not this one, and not this one. In fact, this third one is at 2 pi, and we're not including 2 pi. So my only answer is 0. Well, what's happening here? Well, here's what we know. Remember, there are these things called must checks. One of those must checks is if I have absolute value equal to some algebra stuff. Another one of those must checks is if I have stuff in a denominator. And the third must check we talked about was if I square both sides. Ding! I squared both sides. I have to check for extraneous solutions. 2 of my solutions were extraneous. How would I know that? Well, let's go back and check. Let's take this pi and plug it in, not into this thing that we squared, but into our original equation. Okay, if I plug in a pi, the tangent of pi is 0. What about the secant of pi? Well, I know that cosine of pi is -1, and secant of pi would be the reciprocal of that, which is -1. 0 plus -1, does that equal 1? No, it does not. So that's garbage. Huh, okay. Now, what about sine equal to -1? Well, that's going to be 3 pi over 2. And if I plug the 3 pi over 2 in here, I get another situation that doesn't work. But my question is, what about that solution that we see here, that pi over 2? Let's just confirm it. Second, calculate intersect. I'm going to bring my cursor close to that point of intersection. So it's in between this one and this one. Yes, and I come up with a point of intersection at 0, 1. But we already have the point of intersection at 0. I'm looking for that other point of intersection. So I guess I found the wrong one again. Let's go back and try it again. So here's my graph. Second, calculate, intersect, and I'm looking for something close to 1.57 because that's what I think pi over 2 is. There. And it gives me 0, 1. Well, what's that? Is that not a solution? I'm going to change my viewing window so I can see more of the graph. I need a lot more y stuff in here. -10 to 10. Okay. Oh, it's a vertical asymptote. So there really was only one solution, and that was the solution at 0 because that was a vertical asymptote. Silly calculator graphing vertical asymptotes. Look, before some of you freak out, no, there's nothing that hard on the test, okay? Something on the test might be secant theta, cosecant theta equals 2 cosecant theta. That seems test-worthy. What about all solutions here, okay? So, are you going to divide by cosecant first? If you do, I'll give you a frowny face. Instead, I need to subtract cosecant from both sides, or 2 cosecant from both sides, because then I can factor out a cosecant from each of these terms, secant theta minus 2, and set each factor equal to 0. When is cosecant equal to 0? And this is another place where I want you to be thinking graphically. Think about the cosecant graph. When does this cosecant graph cross the line y equals 0? Well, the answer is it never does. So this doesn't provide any solutions. But secant equal to 2 is the same as cosine equals 1/2. Remember, I'm looking for all solutions. Cosine is equal to 1/2 at pi over 3 and at 5 pi over 3. Okie doke. Great. So that's it for solving. I think I might want to do some trig graphing practice with you, but maybe the solving was enough for today. All right, we'll do one. Just make sure you're comfortable with it. Y equals negative 1/2 secant pi x minus pi over 2 plus 5/2. Okay, please graph this one. You should be comfortable with this. Pause the video, graph this one, and we'll come back and check with mine. All right, so remember I have to graph the cosine version first, and that means I'm setting pi x minus pi over 2 equal to 0, and pi x minus pi over 2 equal to 2 pi. That's pi x equals pi over 2, or x equals 1/2. And here, pi x equals 5 pi over 2, or x equals 5/2. So here's 1/2, here's 5/2. That's the start of one period, that's the end of one period. This is 3/2. This halfway in between these will be 2/2, or 1, and halfway in between these will be 4/2, or 2. I'm doing negative secant. So remember, with negative secant, we want to start low for our cosine and go high, and then back down again. There's our negative cosine graph. Wherever that cosine crosses the sinusoidal axis, we want to draw in our vertical asymptotes, and now we'll be able to sketch in our paraboloids. And so that's our graph. We're going to label these points. We know that this is y equals 5/2, and I go down 1/2, so 1/2, 4/2, or 2, and this over here is 5/2, 2, and this point here, I'm at 5/2 plus 1/2, that's 6/2, or 3, so 3/2, 3. Okay, I hope you were comfortable with your trig graphing. There's definitely graphing on our test, so be ready for that. And what can I say? You're all pros. If you haven't been studying enough or doing enough homework, make sure you step up and do that now, or you'll be very embarrassed when you start taking tests. I'm still really shocked from the number of A students who in the spring semester last year, because of quarantine, they had an A and they stopped working. And when they stopped working, they forgot all their calculus. They still took the AP calculus exam, but I saw so many of those A students, instead of getting that 5 like I was expecting them to get, they got a 2. There were a couple kids who got a 1. And here's the thing. The kids who kept staying engaged and kept going to the Zooms and kept asking questions on the GroupMe and kept watching the videos and doing the work, yeah, they all got 4s and 5s. No kidding. So I'm just going to say, the grades count. And if you want to be successful on that AP exam, if you want to get a good grade, you really need to be watching these videos. You really need to take the notes when you need the notes. You need to be doing all the homework. If you need to practice your unit circle, you need to practice your unit circle. You need to do all this stuff that you, a good student, a smart student, knows how to do. Stop being lazy and do it if you're not, okay? All right, reach out and let me know if you need any help. You can get me through GroupMe. You can ask questions in our Zoom meetings. You can always send me an email if you need. All right? All right. Take care.